Okay, so now we look at one more application of a stack, and for that we need to understand what is called the string tokenization. So, given a string with more than one, say, word, or basically given a string separated by some delimiters, we want to kind of extract each of the what is called tokens in the string. Okay, so for example, you have a string or where you have some integers, and these integers are separated by some symbols or character symbols used as delimiters. What you want to do in this example is count the number of symbols in that string as well as print the sum of the integers in that string. Okay, so you include the string and say string header files. Now declare a string called sample inputted. Now your delimiters could include a blank space, so it's better to use getLine to get input for string. Now the first thing we do as part of this tokenization process is to convert that string to a character array. So now character array is going to have or require space corresponding to the number of individual characters in the string, including, so if your integer is 135 135, is treat each of these digit symbols is treated as a character. So 1, 3 and 5 are three characters in that in 135. Alright, so now you're going to declare a C style character array and treat it as a string. So you need to create allocate space for one more character symbol. That's the terminating symbol or backslash 0, like to indicate the end of the string. Okay, so this length function will return the length of the string. It's a built-in function, the string class, plus 1. So a character array is going to have space for that many character symbols, and you're assigning the base address of the array to this pointer called sample array. And then you call this function strcpy to a string copy. So copy the contents of the string which is in the sample. So sample dot c underscore str is going to return the contents of a string as an array of characters, and you're copying that to the sample array. So that's the first step. You need to generate character array of the given string, and then what you have to do is call the strtok function and pass the sample array, the character array, and then the set of delimiters. Here my delimiters are comma and a blank space. If you have any other delimiters, you will include that too. So it's going to break this character array into tokens, and the first token is pointed by the cptr. It's a character pointer. So now I'm going to process each of these tokens. So for that I need to also keep track of the number of symbols that I have encountered and the sum of the integers I've seen so far. So while cptr is not null, so if cptr is pointing to a null string as a token, that means you're done with tokenization. There are no more tokens. If it is not null, it means it is really pointing to a valid token which has one or more characters. So after you get inside the loop, you create a string out of that token of characters, or the cptr, which is pointing to a set of characters. So you could name this anything you want. I just label it as token. Now you're comparing the contents of whatever you have created a string, the token, with any of these delimiters. If token.compare with the at symbol equals 0 means if token is really the at symbol. So they should exactly match, and if it's exactly matching, then the compare function will return 0. So if any of this is true, that means you've encountered a symbol. I'm assuming that if I did not encounter any of these 5 symbols, then it should be an integer. So 135 or 13 would have been extracted as a token, and I can, so as a string now, so I can use the sty function, string to integer function, to convert the contents of it as from a string to an integer. So that's what I'm doing here. I'm adding that to the sum integers. So this if else is ending here. Now I need to get the next value of a token. So I call strtok function like this. So initially, before the loop, we have to call it like this and pass the delimiters, the character array name and a set of delimiters. Whereas inside the loop, you just say null. That means you have to continue tokenization until you hit null, and then a set of delimiters. So when CPT is pointing to a set of characters that is not null, you will continue further. So after come out of this while loop, we can print the number of operators or symbols you have encountered and the sum of the integers. Okay. So now we'll see an application of the stack class, stack ADT, called the operation precedence. Okay. So for example, if you have an expression like this, 5 plus 8 divided by 4, how would we evaluate this expression? So would we do 5 plus 8 first and then divide this sum by 4, or do we do 8 divided by 4 first and then add 5 to the result of that? So it depends on whether plus or division has more precedence. So there is a rule that we follow to evaluate expressions from top to bottom like this. So if your expression has a parenthesis, then it gets importance, the most importance. Then you evaluate whatever inside the parenthesis before doing anything else. Now if you also have exponent, you evaluate the exponent from right to left. So 3 underscore raised to 2 raised to 4, then you evaluate 2 raised to 4 first, and then whatever is that, then 3 raised to, that's 16. The next precedence goes for either multiplication or division, and if there's a tie, you evaluate from left to right. Similarly, addition subtraction is getting the last precedence now, and if there's a tie, you evaluate things from left to right. So now you can break the rule. So you have 5 plus 8 divided by 4. So division has more precedence than plus. So you do 8 divided by 4 first, and then 5 plus 8 divided by 4 is 2. And also you have 8 and 4 as integers. So what we will do is an integer division. That means you get only the quotient. So 12 divided by 6 star 3, here you have multiplication division, both have equal precedence. To break the tie, go from left to right. So it is 12 divided by 6, which is 2 times 3, which is 6. Then 4 times 5 divided by 2 minus 7 plus 3. Now you have division, multiplication, equal precedence, and tie, so go from left to right. So 4 times 5 is 20 divided by 2 is 10 minus 7 plus 3. So 10 minus 7 plus 3. Again tie, break from left to right. So 10 minus 7 is 3 plus 3 is 6. So now you have 4 star, and then inside the parenthesis you have this. Now you evaluate things inside the parenthesis. Now here also you have one more parenthesis, so you evaluate that first. So it's 2 minus 7 is negative 5. 5 divided by negative 5 is negative 1, that's the quotient. Plus 3, which is, so negative 1 plus 3 is 2, so 4 times 2 is 8. So if it is what we have seen so far, expressions like this, and the format of writing expressions like this, we call it as an infix format. So infix format, you always have an operator in the middle, and then what is called a left operand, and then the right operand. So you have something like this: plus in the middle, then 2 and 3, or the left and right operand. Now that's called infix format. Now you could also write expressions in two other format, and that's what you're going to see, how to evaluate an expression. Now all the three formats are equal to each other in the sense that if the value of expression evaluated in one format is evaluated in one format, it should be the same as the value of expression evaluated in the other two formats. 2 plus 3 is evaluated as 5 in all the three formats. So what are the other two formats? So they are called the prefix and postfix format. So in prefix, the operator is written first, followed by the left operand and the right operand. So prefix means the operator gets more importance and written first. Postfix, you write the operator at the end, and then you write before that the left operand and the right operand. So in the case of 2 plus 3 is infix, you write plus first and then 2 followed by 3 for prefix, and for postfix you write the left and right first, so 2, 3 followed by plus. Okay, so to evaluate an infix expression, you need to break the ties using the rules that we have seen so far. Now there won't be any such ambiguity when you evaluate a prefix or postfix expression. Okay, so because in both prefix and postfix expressions, each operand will be associated with only one operator, and hence no need to use rules for operator precedence. So each operand, which is like say the left operand or right operand, will be associated only with one operator, and there won't be any need to break the tie. Now we are going to see how to convert expressions like this to prefix or postfix, and you will see that each operand is associated with only one operator, as we see how to evaluate postfix or prefix expression. So let us do this first conversion: a plus b star c. So this is infix. So try to think about how would you evaluate this infix expression. So there's no parenthesis here, so we have to break the tie in favor of multiplication. So we will do b star c first, and then what is the result of that, you will add a to it. So we can say b star c as star bc. So that is one term for this plus operator. So it's a plus that term. So now again continuing the prefix conversion, so we wrote b star c as star bc. So then this a plus, the result of that as plus followed by a followed by star bc. Now if you do a postfix, b star c can be written as bc star, then a plus bc star can be written as a bc star followed by plus. That's the postfix, and this is the idea we are going to use now to convert a prefix, so infix to prefix or infix to postfix expression. So let's see an example. So you have again a star b plus c star d minus e. There's no parenthesis, so we have to decide how would you evaluate this as an infix expression, breaking ties. So you have two multiplications, so you give precedence from left to right. So you will do a star b first, so that's one result term, and then whatever the result is plus c star d minus e, so star now, so you will do c star d. So whatever the result of a star b, that's one term now, plus another term c star d minus e. So plus and minus, you will do minus plus first, so a star b plus c star d, whatever the result of that is, minus e, and then you will get the final value. So that's how we will evaluate this as an infix expression: a star b plus c star d, then do the plus and then minus e. So now let us convert this to a postfix expression. So you can write A star B as AB star, similarly C star D as CD star. So what you're having is AB star plus CD star minus E. So now you can do plus at the end, A B star as one term, CD star as another term, left and right operand, then plus, then this minus E. So we can write A B star CD star plus as left operand, E as right operand, minus. So now you can remove all the parentheses and then you can write this as AB star CD star plus E minus. So this is the postfix expression. So now we can see how to evaluate this postfix expression and get an answer, which is going to be the same as evaluating the infix expression, the corresponding infix expression. So the rule for evaluating postfix expression, the procedure is this: scan the expression from left to right. Now as you scan the expression, if you see an operand, push it to the stack. If you see an operator, pop the stack twice. The first time you pop the stack, what you get out of a stack is the right operand for that operator. The second time you pop the stack, you get the left operand for the operator. So that's important to remember. So in the case of evaluating a postfix expression, the first pop is the right operand and the second pop is the left operand. And then you do the whatever the math depending on the operand and push the result back to the stack and continue the process. Continue scanning the rest of the expression. So after you scan the last symbol or whatever the last thing in the expression, then you will be done with evaluating it, and then do the corresponding processing. Will be done with the evaluation. So let us see how to evaluate this. So you have AB star CD star plus E minus postfix expression. So go from left to right. So you see an operand A, so push it to the stack, and I'm just showing some values also to see how the math is done. Then you encounter B, which is an operand, so you push it to the stack, and then you have the star. So that means it's time to pop out. So you pop the stack twice. The first time you pop it, you will get a right operand, so that is the right operand B. And second time you pop, you get A. So stack is kind of temporarily empty. So you do A star B and then push the result back to the stack. Okay, so what the result of A star B is? In this case it is 6. You push it to the stack. Then you encounter C, so push it because it's an operand. D is also an operand, push it. Then you encounter a star. So you need to pop the stack twice. So the first time you pop out, you get out D, which is the right operand, and then second time you pop, you get C, which is the left operand. So do the math, C star D, and push the result back to the stack. And then you encountered a plus. So you have to again pop the stack twice. So C star D becomes the right operand, A star B becomes the left operand. Do the math, A star B plus C star D, and push the result back to the stack. And then you encounter an operand E, so push it to the stack. And then you encounter a minus, so pop the stack twice. E becomes the right operand, A star B plus C star D becomes the left operand. Whatever the result of it is pushed back to the stack, and then you try to scan the rest of the expression. You don't see anything else to scan. Then you finally pop out the stack once, and that's the result, or that's the final result, or the overall result of the expression. Okay, so let us see an example of how to evaluate a postfix expression. So include a stack. Now here I'm going to use integer stack. Okay, so the expression is basically the integer value separated by a comma as a delimiter, and then you could have plus, star, whatever operator in between the delimiters. Okay, so if you want to do 2 plus 3, you would input again you assume here you are inputting the expression as a postfix expression. So if I want to evaluate 2 plus 3 using this code, I should have converted that infix expression to a postfix expression, and what you input is a postfix expression. So 2 plus 3 should be is in postfix is 2 3 plus. So you would input it as 2 comma 3 comma plus. If you have 10 plus say 20, then you could input it as 20 comma 10, sorry, 10 20, 10 plus 20, right? So you would input left operand first, so 10 20 plus. So it should be input as 10 comma 20 comma plus. Okay, so assume you have input expression, and top part is of the code is just preparing it for tokenization. So do all the character array conversion and the string copy, and then cp char star cptr equal strtok, pass the character array and the delimiters, as I said, comma, and you could have blank spaces to make sure you take care of it. And then cptr is not equal to 0, get inside the loop and convert that to a string, and check if you encounter an operator now. So have a variable boolean called isOperator, and you set it to false. If it is, now you compare the content of the token to one of the operators. It's either a star, plus, division, or minus. If it's equal to 0, that means what you have encountered now is an operator. Check is operator is true. Now if you now check if it's an operator or not. If it is not is operator means, so if its operator is false, not is false is true. So that means if its operator is false means you have encountered an integer, so convert the integer token, string token, to an integer value and push it to the stack. So that means you are pushing an operand to the stack. If you encountered something which is operator, then not is operator will be false, because is operator is true, not of true is false. So get in, so check if you encountered is an operator. So if you have encountered which is something which is an operator, then it's time to pop the stack twice. So the first time you pop, you get the right operand, so stack.pop, and whatever that comes out, you treat it as the right operand. And second time you pop, treat it as a left operand. And then whatever the operator is, do the corresponding match. So if token.compare star if equals 0 means you have to do multiplication of left operand times right operand and push the result back to the stack. So I use a temporary variable called result and push that result back to the stack. Else if it's a division operator, do the division left operand divided by right operand. See, it's very important to make sure you have the right, left and right operand. So that's why you have to understand this. So the first pop value is the right operand in the case of postfix expression, and it's the left operand. Second pop is the left operand. Then if it's a plus or minus, do the math accordingly and push the result back to stack, and keep continuing this. And in order to continue to the next token, you have to call this strtok null and then the delimiters and pass equal to cptr equals that. And then once you're done with scanning through the entire expression and tokenization, then you can come out of the loop and print the final result. So you have to pop the stack once, and that will store the final result of the expression. So what we saw is evaluating a postfix expression. So now let us see how to do a prefix expression. So for that, again, given an infix expression, you need to know how to convert that to a prefix. The rule is, the process is the same. So try to first decide how to evaluate the infix expressions, put all the parentheses required that you need to break the ambiguity. So a star b plus c star d result minus e. So right now, things individually in the prefix format and then put things together. So a star b will be evaluated as star a b in prefix, then c star d is star c d. So it's basically, this is a star a b is the left operand plus the right operand is star c d, then minus e. So we break the tie in favor of plus, and then so it's plus is the first thing in the left operand and the right operand. So the whole thing is now one operand, the left operand for minus, and then e. So you will do it as the operator followed by the left operand and then the right operator. Now finally, when you are done, you remove all the parentheses symbols and just simply writing the expression like this. Now how to evaluate this prefix expression is you scan from right to left. Okay, so instead of left to right, you scan from right to left. Or you could reverse the string and scan from left to right. Doesn't matter, either way it's the same thing. So you scan, say for example, from right to left, or use the reverse function we saw in the earlier code and convert and reverse this string. Now when you do that, you have to be careful when you work with numbers, integers. So if you have 1, 2, 12 as an integer operand, then when you reverse it, it becomes 2, 1. So you have to make sure you reverse it back before you do the STOI. Okay. So if you when you tokenize and get it as a token string, you again have to make sure to reverse it back. Alright, so let us see. So you scan from right to left. This example, just for visualization, you could reverse it and scan from left to right also. Alright, so you encountered E, which is am I showing it here? Yes. Alright, so you encountered E, so which is an operand, so you push it to the stack. Then you encountered D, which is an operand, so push it to the stack. Encountered C, an operand, push it to the stack. Now you encountered an operator star. So whenever you encounter an operator, the rule is like to pop the stack twice. But here, the first pop is the left operand, not the right operand, and the second pop is the right operand. So the first pop is left operand, which is C, and the second pop is right operand D. So you are really doing C star D and pushing the result back to a stack. So you have E and now C star D. Now you see a B, so push it to the stack. You see an A, so push it to the stack. Now you see a star operator, so pop to stack twice. The first pop is the left operand A, the second pop is the right operand B. So really evaluating A star B, so push the result back to a stack. And then you see a plus. So you pop the stack twice. The first pop is the left operand A star B plus C star D. Push the result back to the stack. So minus, again an operator, so pop the stack twice. So this is a left operand minus the right operand, and push the result back to the stack. And then you're done with scanning expression, so pop the stack finally once, and that's the value for the expression. Alright, so with this we'll stop the video.